Hello, everybody. Welcome to our first birthday celebration. Today, we're celebrating 1 year of Seds Online. Just to give you some background, over the last year, we've had 49 live webinars. We've had more than 4,000 attendees at our webinars. We've hosted 2 international conferences, the Carbonate Forum and the BSRG AGM last year. We've hosted 2 international, those are 2 international conferences, 200 coffee breaks, more than 200 of those under our belt. Our webinar recordings have grossed over 12,000 views to date. So we're very pleased with what we've done so far. But this has all been possible really due to the community. Without the community, none of this would have been possible. It's our volunteers on our committees, our coffee break coordinators, but most of all our speakers. Without our speakers, none of this would be possible. And in fact, a couple of our speakers are rejoining us today. We're not resting on our laurels. We're going to be making a lot of changes over the near future. Got some really exciting developments in progress. The first of those, as the eagle-eyed amongst you may have noticed, we have a new logo. We've launched our new logo today. That's our new Seds Online logo. And as from tomorrow morning, bright and early, we'll be launching our crisp, shiny new website. So a new website, we've tidied things up, rearranged things, and that will be going live tomorrow morning. Enough about the advertisements. So without further ado, the first of our new events, the first Seds Online Great Debate. And we're hoping to make this a fairly regular feature. We're hoping to do this maybe every 2 or 3 months throughout the year from now on. Let's start with a bit of a background, because this is going to be new to a lot of our audience, this debate format. So what we're going to do is we're going to start with a quick poll. At the beginning of the debate, we'll have a poll and we'll get everybody's opinions on our topic. Then each of our speakers will have 8 minutes to present their arguments. Firstly, we'll have the leader for the argument, then against the argument, then the seconder for the argument, and the seconder against. Then perhaps some would say the most important part of the debate. Now it's the turn of you, the audience, to give your opinions. And we really do encourage everybody with an opinion to make that opinion known politely. All you're going to have to do, and I'll remind you of this at the time, is raise your hand using the raise hand button on your computer. Just raise your hand, and then I'll invite people to speak. We'll invite you to turn on your microphone and video. You'll have 1 minute to raise your point, to give your argument. Now, 1 minute doesn't sound long. Talking for a minute can be actually quite a long time. Remember, it's your main presenters have only got 8 of those minutes, so you've got an 1/8 of their time. So it's quite a long time. As with any debates, of course, keep those comments nice and respectful. After all the audience contributions, each of the sides will have 5 minutes to sum up. They will reply, they will comment, they will perform rebuttals to maybe what the other side said, and then we'll move to the final vote and announce those votes. If anybody has any questions at any time during the great debate, then simply send those questions to Seds Online and Valentin will try and help you. Now, these need to be technical questions. You can't communicate with other members of the audience. You can't communicate with the actual presenters themselves. If you want to raise a point to a presenter, you can do that in the audience slot orally. To clarify, that chat is turned off for any other communications other than technical communications. So please, if you need it, that's what it's there for. Right, okay. Let's get started with the actual debate. Today's motion, the recent really is the key to the past. We have 4 excellent speakers for you lined up. Speaking for the motion, we have Jeff Peakall. Jeff is the Professor of Process Sedimentology at the University of Leeds. His research encompasses a diverse range of topics, encompassing sediment transport, sediment deposition, particular interest in deep water processes and submarine channel systems. Jeff is joined by Shahin Dashtgard. Shahin is Professor of Earth Sciences at Simon Fraser University. His research is focusing on 2 main topics. Firstly, he's looking at resolving depositional cyclicity and evolution of convergent margin basins. Secondly, he's evaluating fluviotidal strata through time and space. Jeff and Shahin's opposition are William McMahon. William is postdoctoral research associate at the University of Cambridge. His research focuses on pre-vegetation Earth and the emergence of metazoans and subsequent terrestrialization of the continents. I've had to practice that so many times, terrestrialization of the continents. Focusing on Mars, William's also looking at how different biological processes, of course, Earth's sedimentary and stratigraphic record to differentiate from that of other planets. William is joined by Cathy Hollis. Cathy is the chair of carbonate geoscience at the University of Manchester. Her work is focusing on sedimentology and diagenesis of the carbonate systems, particularly looking at the roles of paleofluids and post-depositional processes and how they affect pore geometries, pore sizes, shapes, connectivity, etc. As promised, before we start, I want to go with a poll. So Valentin, please can you activate the first poll? Oh, look at that. He was waiting for that. So there's your first poll, everybody. So we're going to, I'm seeing the results. I guess nobody else is. The people, please do vote here. I'll point out, I'll give you a few seconds more to vote here. It is totally anonymous, so don't worry. Nobody's going to think you're a fool. There is no right answer. There is no wrong answer. Although the speakers may disagree. There is an opinion. Let's all vote, and we'll have another poll at the end and see if our speakers have managed to sway anybody one or the way or the other. I'm still seeing people voting, so I'm going to give it a few more seconds. Few more seconds. Okay, things have settled down. Okay, right. So Valentin, please can you close? Oh, another vote. That was a very last minute vote there. Valentin, please close the votes. Thank you. That was 1 minute. Valentin, are you there? Thank you. Okay, Valentin's closed that poll, so that's great. Thank you very much, Valentin. Right, okay. Now we're done on that. I've got a very long script here. Right, now I'm going to call on a first of our speakers, Jeff. Jeff, you have 8 minutes. If you could start sharing your screen now. I'll tell you when you can start. So, as I said, Jeff is presenting for the motion. He's the first speaker, the proposer for the motion. Jeff, you have 8 minutes and basically start at your leisure.
Hi, everyone. So I have to say, this is very strange. I've spent my entire life, I think, arguing against things. But today I want to speak in support of the motion that the recent really is the key to the past. And of course, this is a variation on the famous maxim of Sir Archibald Geikie, that the past is the key to the present, and of course based on the pioneering work of Sir Charles Lyell. I suspect that we'll soon be hearing about Sir Stephen Lockyer, as he's updated this to the recent. And that, of course, for geologists is the Holocene. And so we're talking about the last 10,000, 11,000 years or so, up to and including the present. But what do we mean, I suppose, by the key? I mean, the key means something important, crucial, but also a physical key, like the one I put up here, is something that we use to unlock something. And I think that's the analogy here, that we're looking to unlock the past. And so the revolution in terms of sedimentology started early on, from the early 1900s. The likes of Sorby and things was doing experiments, looking at flows and looking at what sediments were deposited from them. And this led to, I think, the big concept in sedimentology, which is, I think, dominated much of our science, which is the process product approach as we see in this chocolate factory here. And that's where we can study the underlying processes, be that in modern environments, in the lab, using numerics or using cores and so on in recent sediments. And then we can see, certainly in the case of the modern things, we can see the deposits, the result from that. And so we get a really good understanding of how we link flows to the product, and therefore we can interpret our sediments with confidence and in detail. And of course, this is an approach that still dominates a lot of our subjects, and making numerous groundbreaking advances today. I suppose I'd pick a few. I mean, supercritical bed forms has been a way of changing how we look at the past, through to, I suppose, transitional clay-rich flows, and the surprising result recently that I was reading about how you get low-angle crossbedding from giant river dunes. So, and I think when you look at a modern sedimentology textbook, it very much reflects this process product approach. The other great thing about the recent is that we can get high resolution dates and other allied information if we use sort of shallow cores and things like that. And then we can link these to tell us about rates of sedimentation, and we can link to external forces such as tectonics and earthquakes or climate change, and so that we can understand how they result in sediments. And we can also, I think, identify individual event beds in multiple locations, and therefore look spatially at how things alter over time. So I think of things like tsunami, or in my own case, we can link things over tens of kilometers on the ocean floor. And I think these approaches have served us well. And that's because the underlying physics, of course, hasn't changed over Earth time, over geological time. And so the basic mechanics, if we're looking at sediment transport of my jelly babies, it'd be a shame, but they've not really, in terms of the basic mechanics, they've not really altered over all that time. The real challenge when we look in back in time, be that in Earth history, or I've chosen an example here from Mars, is to understand how that we need to recognize that, of course, the range of conditions has altered over geological time and across different planets. But the great thing about learning from the recent is if we understand physical laws, then we can account for some of this, at least to some degree. It depends on our level of understanding. And we can use experiments and numerics to investigate such conditions. So in the case of Mars, it has this nice simple case, it has much lower gravity than Earth. So of course, we can't actually directly test these things on Earth, but if we understand gravity, at least on some levels, the levels we need to here, we can account for, in terms of sediment transport and deposition for this. Of course, I suppose the one thing that has changed, I'm sure you'll be hearing more about this from our opponents today, but of course, outside of, say, Lancashire, then we've seen evolution through Earth history, and of course, life has appeared in all its glory. And I think life has had an enormous effect on sedimentation, and yet I think if you read a modern sedimentology textbook, we rather restricted this to a few areas of sedimentology, you know, in particular trace fossils, and I suppose especially carbonates. Yet the influence of life, I think, is far more pervasive on sedimentary processes, and I think this is really one of our grand challenges in the field. Yet, I would argue here that if we're to understand the role of life, then once again, we need to go back and investigate life in the modern and in the recent if we're truly to understand the mechanics of this. And with that in mind, here's some of my own work. I think this revolution has started, but we've been looking at biological goo in here, the sticky stuff that comes from diatoms and other organisms, and we show that it has an enormous effect on sedimentary bed forms. And I think the Liverpool group, I know they've, just to pick another example, they've done some fabulous work looking at biofilms and the role of they play in clay coats on sand grains, and of course that's crucial for long-term diagenesis. So I think this has started, but there's clearly a lot more to do. If we think about things without the recent, though, then we're not left with, we have very little left to work with if we take away our understanding of present and recent processes in here. I think you need a lot of faith as a field geologist as it is. You know, when I look at rocks, they're complicated, aren't they? When I look at them, they tend to drive me back to the recent, to the modern, to try and understand them better. But if as geologists we don't understand the mechanism, then there's always the risk, of course, of getting things wildly wrong. And of course, geology is littered with such examples. And of course, we can even run the risk of mixing up correlation and causation if we don't understand mechanics.
Your 1 minute warning.
So, in order for us to achieve then real depth of understanding of the past, if we're to unlock that, then we need to use, I think, all the approaches that we can from the recent, including dating of sedimentary cores and the extraction of other information from those, observations from modern systems, along with laboratory experiments and numerics to understand these processes, these mechanics. I think this is the case for life as well. And we really need to understand far better the role of life and of evolution in sedimentology. But in order to do that, our greatest asset is to study life in the modern and the recent in order to unlock the past. So I urge you to support the motion that the recent really is the key to the past.
Well, that was absolutely perfect typing. People can probably hear my computer alarm going off, which I actually downloaded this morning and don't know how to stop. There we go. Right, okay. Perfect. Thank you very much, Jeff. Perfect timing there. So thank you very much. So Jeff has put forward the first speech for the proposition. Now I invite William to speak for 8 minutes against the motion. If you'd like to share your screen, please, William.
Can do. Got it?
Perfect, that looks good. So if you'd like to proceed at your leisure.
Well, yes, I'll do well to match Jeff's level of punctuality. You'll see me rattle through some slides at frantic pace in the next 8 minutes. Here's the motion, the recent really is the key to the past. I'd say that's a rather overconfident exclamation mark. I'm going to replace that for the time being with a more hesitant question mark, because this is the idea which we're testing and which myself and Cathy are arguing against today. So a slide of background, just because over the course of making this slide, I actually learned that there's a rather unsung hero when it comes to uniformitarianism, and that's William Werrell, who actually coined the term in an anonymous comment of Charles Lyell's Principles of Geology. So whilst Lyell often gets the credit, this guy, William Werrell, was actually the first to say the present is the key to the past. But it's one thing comparing, volcanism today and saying we have volcanic eruptions at the present day, so this was probably also the case in the Devonian. But what about us as sedimentologists when it comes to interpreting our sedimentary outcrops to make our informative decisions on Earth's ancient history and evolution? And often this involves coming up with conceptual models of different sedimentary environments, be it siliciclastics or carbonates. This is a rather famous one of estuaries led by Robert Dalrymple that I'm going to refer to time and time again whilst I make my arguments. But many people before our debate today have suggested that when it comes to sedimentology, uniformitarianism needs some refinement. And one of the best examples of that I found was in a rather fun paper led by Stephen Gould, Is Uniformitarianism Necessary? And if you're one who really enjoys blunt critiques of the earth sciences, I'd recommend this paper. It's rather amusing. But he split uniformitarianism with sedimentology in mind twofold, into substantive and methodological. So the foremost of those assumes natural processes operate at uniform rates, okay, so uniformity of process. Whereas the second, and Jeff touched on this, is the assumption that natural laws are invariant in space and time, okay? And it's these two ideas that myself and Cathy are going to test, myself with clastics and Cathy with carbonates. So Jeff was spot on again when he said that we'd be focusing a lot on the evolution of Earth's biosphere. Okay, we are. The bottom figure here is a rather fun paper in PNAS where these authors tried to estimate the biomass of all different domains of life on the planet today. And they found that most are dwarfed by plant life, Earth's flora. I can't remember the exact number, but it's something like 83% of Earth's biomass is locked up in flora, okay? But there's a whole host of polygons here in this diagram, but it's important to recognize that these polygons have been anything but fixed through geological time. So therefore, any eco-engineering capacity that they have, any chance of mediating sedimentary processes and sculpting the sedimentary record, those have also shifted. And I'm going to give you some of those examples in the upcoming slides before you make your decisions. One of the most heavily debated, if you like, or at least discussed, is this idea of point bar sedimentation. So I've just highlighted this sinuous channel in this diagram of Robert Dalrymple's. And the sedimentary stratigraphic expression of these point bars, these meandering channels, is one of lateral accretion. Okay, this is when you can see that paleoflow is broadly orthogonal to an inclined accretionary surface. And I've shown an example of a carboniferous point bar deposit from Ireland at the bottom, but these are relatively common stratigraphic expressions. And yeah, they're far more complicated than just this, with various expressions of dilation or translation or downstream migration. But broadly speaking, when we talk about meandering, we think about lateral accretion deposits or inclined heterolithic stratification. But this is one type of sedimentary structure that has not occurred in equal abundance throughout geological time. And one particular stratigraphic expression of these, inclined heterolithic stratification, shows a broad appearance, or at least a vast increase in abundance, around the same time plants are appearing on the continents for the first time. And there's a rather famous one from the Scalby Formation up in the north, me vaguely trying to orientate my hand to show the direction of accretion there. But these type of muddy or heterolithic inclined strata, this is not a common signature in the Precambrian. There are a few exceptions, but by and large, they increase in abundance after plants have started to increase flow resistance. Their above ground topography baffles sediments, reduces Hortonian overland flow, increases the deposition, the likelihood of cohesive muds, which add more stability. Their roots mechanically bind the channels, increasing flow resistance again. And all this enables or facilitates, or better facilitates, meandering conduits and the preservation of inclined heterolithic stratification. This has already been debated in an IAS special publication, so there's a few papers there. I'll leave it. I'm sure we're going to talk about it. But people suggesting, like great paper by Adrian, suggesting that maybe sandier equivalents of this have been misunderstood or misrepresented in the Precambrian. My own contribution suggesting that maybe we're missing large-scale meandering channels in the Precambrian. But whatever your debate or your problem with this idea, you have to account that this change is tangible, that you can't deny that inclined heterolithic stratification is far less common in pre-vegetation stratigraphy than sin-vegetation stratigraphy. Whatever your methodology, you have to account for that unidirectional one-off transition. And it's not just a story with point bars, but also muds, a great repository of information which we use to infer ancient climate, carbon cycle, plate tectonics, biological evolution. Mud is key, but again, it's not fixed through geological time. So the bottom, it doesn't matter if it's a mud flat or a coastal plain or a floodplain, we don't see fixed mud abundance throughout Earth history. So a paper of my own with Neil Davis, we've shown in this bottom right that in alluvial formations throughout the Precambrian, each one of those dots is a different alluvial formation somewhere on the planet. The y-axis shows mudrock volume, total mudrock volume, and it's pretty much a negligible percentage all the way up until the Silurian, all right? And then plants evolve, and again, I've already mentioned the binding and baffling tendencies or capabilities plants allow, and suddenly we use that full spectrum. Suddenly we're additionally retaining more mudstone because the above ground plant parts are capturing it and forcing its deposition. The below ground roots are binding our channels and increasing the likelihood of preserving the floodplain sediments where our mudstones are predominantly being deposited. 1 minute. Good stuff. We've also got new ideas about production and flocculation and all these things that are increasing the likelihood of preserving muds. I was going to talk about tidal prism, but I won't today. But this has a real effect into the process sedimentology of things. Is there a clay mineral change associated with this? A lot of people are suggesting yes. This new study out from the Mesoproterozoic showing that clay mineral content in the Precambrian lacks the pedogenic clay minerals that we see in syn vegetation strata, mostly just having detrital clay minerals. Yeah, and it's not just linked to plants or vegetation, things like cherts being related to silica biomineralizing organisms. I put in soul marks just as a gift for Jeff to debate. These things have been suggested to be more abundant in the Precambrian before bioturbating critters. Same for flat pebble conglomerates.
Okay, if we can wrap up now.
Yeah, and I'll finish on this slide saying what you really need to appreciate is that these different structures have just distinct facies distribution shifts or frequency distribution shifts through time that are related to evolving biosphere. So the further back in time you go, the less appropriate, or the least appropriate these ideas of uniformitarianism become. Yeah, the physical laws of fluid sediment interaction haven't changed, but the theatre in which they operate has evolved through time because of Earth's evolving biosphere.
Thank you, William. Thank you, William. Okay, terrific. Thank you, William. So you've now heard the first speaker against the motion. So I'd like to call upon our second speaker for the motion, Shahin. If you can screen share with us now, please. Audience, remember, after the next speaker, after Cathy, you will be able to put forward your thoughts on this. So if you have any thoughts, please start thinking what you're going to talk about for 1 minute. Okay, Shahin, are you ready?
I am.
Right, okay, kick off in your own time.
Okay, awesome, thank you. So we've heard a lot of good arguments, I think, for how the Earth has changed. And fundamentally, the difference in our approach to the term, the recent really is the key to the past, and what we're hearing is the fact that uniformitarianism is not necessarily the same as the phrase that we're actually debating. Uniformitarianism is the idea that things have not changed through geological time. That's obviously not true. What we're talking about is the fact that the modern and the recent time is actually how we start to understand the rock record and interpret everything it is we see in the rock record. Now, I liken that to a painting. I look at a painting, or you walk into a room, you find a painting you like, and you say, wow, that's a really nice painting. I need to understand how that painting was done. I need to understand everything about that artist and the work that he does. You might look at the way he uses strokes in that painting. You might look at the chemical signature of the paints that are actually used, the preferred colors that are used, what type of brush is used. Is there any leftover hairs on the painting? In fact, you might even look at the canvas and say, well, what is that particular canvas and what is it made of? In this case, maybe they used a lambskin. Now, you go elsewhere, you look for other paintings made by that artist, and you find objects that look very, very similar. Not a problem in recognizing that those are both made by the same artist. But what happens if you come across a painting that is very, very different, or looks different at first glance? Well, there you start to use the deductive reasoning. You look at the painting, such as the one we see right here, and you might say, well, he uses a very similar stroke style. Obviously, the chemical composition of the paints are similar, but even though there's different colors and a different brush type, we see that they're still on a lambskin. So we would make the argument then that it's the same artist, but probably from an earlier stage in his career. Now we're using our modern art, our standard, to interpret and understand what it is we're seeing in this particular example. What if we see something completely different? In this particular case, we see that the chemical composition of the paints are very, very similar to what we have with the other paints. And maybe it's also done on a lambskin canvas. Awesome. However, a very different stroke style is being used. We're seeing different colors being applied, and there's a different brush style. So we interpret this then as being the product of a different artist. Now, all of this is premised on our understanding of what our standard is, our original piece of art. In sedimentary geology, this is our standard, the modern Earth, the recent time. It's from this standard that we start to understand and interpret everything we know about the planet. It's actually the exact same standard that we use to interpret everything we know about other planets. When we recognize differences, we recognize them based on the fact that they differ from present-day Earth. We look at laboratory experiments to understand physical processes, to quantify those. We use those data in field studies to understand and decipher what's happening in those particular environments. We do that in the rock record as well. Paleontologists rely heavily on biomechanical studies of modern organisms to interpret what animals were doing in the past. And we feed all of that data into modeling software to predict what happened in the past and to predict what happened in the future. The Earth, the present day Earth, is our standard for comparison throughout time. It always has been. It is our key for resolving what's gone on throughout geological time. I give you a few examples. This is a great piece of work done by Prilio et al. In 2014. They looked at unidirectional current flow versus orbital flow, and were able to determine what sorts of bed forms are formed at different flow conditions. Now, by knowing what those bed forms are, by understanding what the internal architecture of those bed forms are, we can then develop models to then predict and interpret the rock record based on the types of structures that we observe. We start to understand and decipher the ancient Earth based on our observations of the modern Earth. And this is a fundamental component of physical sedimentology. If you look at something like the picture at the bottom here, of a planar tabular cross stratification, almost moving towards trough cross stratification, there probably isn't a physical sedimentologist anywhere on the planet who wouldn't say that those are dunes and that represents some sort of unidirectional subcritical flow moving in water. So we look at that and we observe it and we say, yeah, that probably tells us we're looking at something very similar to what we observe here in the top with a unidirectional dune scale bed forms moving in the direction of flow. So we're basing our interpretation of the rock record on our modern understanding of processes and what's happening in the modern world. In this case, as with all other cases, we're relying on the recent record to interpret the ancient record. There's never any change in that, regardless of every argument, regardless of every difference that we observe in through time, it always comes back to how does it differ from the modern world. We always premise it on the recent. For example, or taking it to probably the most extreme, the paleontologists are perhaps the most guilty of doing this sort of work. Now, if you look at this picture in the top right here, that's a picture of an inoceramid, but in reality, it's a picture of a rock. Understanding that that isn't a rock actually relies on the fact that we understand that it looks very, very similar to modern organisms. Now, I look at this inoceramid and I say, oh, you know, that's actually a really nice piece. I see the hinge in there, and I can, based on my understanding of what modern clams that would look very similar to that do, I'm going to interpret that that thing was probably sitting on the seafloor and filter feeding. And it grew to a large size, but it never burrowed and it probably never swam. I'm going to guess that if I looked at, say, this bottom left-hand corner, that its internal structure and internal organs probably looked very, very similar to that. Why would I make that interpretation? I base that 100% on my understanding of modern animals. And this is done for all paleontologists throughout time. It's comparison to the standard. So whether those things are different, whether we see differences throughout time, whether we see similarities, becomes rather irrelevant, because that's not the point. The point is that the key for deciphering and interpreting the rock record is always the recent record. We rely heavily on the Earth to actually understand and interpret whatever it is we see. So I show this picture, the Earth and the key, and how it actually is, how we unlock things. And there's a couple things that were mentioned earlier that were brought up in Will's presentation that I want to touch on here. In particular, liverworts. What is a liverwort? Did we look at the Silurian and say, hey, those are what liverworts look like? No. We looked at the modern, we identified what liverworts were, and then we looked for expressions of those in the ancient past.
You have 1 minute.
Okay, yep. We rely 100% on the modern Earth for resolving what it is we look at. We use the modern Earth in the recent time as our key for unlocking everything in the ancient record. And in sedimentary geology, this is perhaps more true than it is in any other science. So I'm not going to belabor the point. I think we really have tried to put the emphasis here that the recent really is the key to the past. And with that, I'm going to rest our case on behalf of Jeff and I, say thank you. Hopefully you agree.
Well, thank you very much, Shahin. There's probably rapturous applause, I'm sure, from the audience for all of our speakers so far, but you're actually getting applause there from William in your opposition. Next speaker, we have a real challenge there. They dropped the mic at you, Cathy. So, Cathy, if you can share your screen, please.
I will. Just let me unmute myself. And can you see the full screen display there?
I can see your screen. It looks perfect. So beautiful corals carbonates. So please proceed at your leisure. Thank you.
Thank you very much. So I'm going to support what Will's just been saying and speak about why I don't think the recent is the key to the past in the context of carbonate sediments. And in the interest of time and for the sake of simplicity, I'm just going to focus on shallow marine carbonates, as these are the most common carbonate sediments that we encounter and probably the best understood as well. And I'll start by immediately referring to Jeff's opening statement about the importance of physical processes, which I completely agree with. But when we think about carbonate sediments, then we have to remember that we're dealing with biogeochemical precipitates. And so these are going to be very much influenced by a whole range of other parameters other than just physics. So that's pretty much going to be the key to what I'm going to say. Carbonate platforms are one of the best records that we have of shallow paleo environments because they're organic in origin, and they're also a geochemical archive of our ancient ocean chemistry. And because our ocean chemistry has changed through time, it's also a proxy for shifts in the Earth's atmospheric composition and a proxy for past climate. So hopefully with all of this, I'm going to show you that we can see that the past was very different to the present and to the recent, and therefore there's a lot we can actually learn from the past rather than relying on the recent to help us with our interpretations. So let's start with modern platforms. As we are all familiar, most modern carbonate platforms, such as we see here, this is with part of the Great Barrier Reef Complex, and here in Belize, we're forming in warm tropical seas with good levels of light, probably mostly within the between the Tropic of Cancer and the Tropic of Capricorn, which corresponds to the sort of 20-degree isotherm. And these are all areas of limestone accumulation from skeletal and non-skeletal carbonate grains. And all of them support this very rich and diverse ecosystem, such as we see here, where we have coral algal reefs building up. And as such, we develop these very familiar structures whereby we often have broad, shallow lagoons, and then this steeply dipping front where this ocean water goes very, very dark blue, where organisms have been trying to compete for light and are trying to keep up with sea level, and then there's a sudden drop off into the ocean. So we see these very shallow, wide platforms dropping off very quickly into deep water. And where we don't see that, perhaps in UAE coastline, then we form slightly lower angle carbonate ramps. So we're very familiar in the modern day of this sort of polarized view of whether a carbonate platform is a shallow dipping ramp or a steeply dipping platform. But let's go back and think about what might happen in the past and focus first on evolution, because we've touched on this already. And we're very familiar with diagrams such as this, which highlight how modern life has evolved. And it's only really in the last few million years that our atmosphere, biosphere, and hydrosphere, and particularly the configuration of our oceans, has resembled what we see today. And all of these spheres combine to influence the geosphere. So for example, if we go back 2 billion years to oxygenation of the atmosphere and the development of multicellular life forms, we had a very different world then to when land plants started to evolve, and we've touched on that in the Paleozoic. And that significantly contributed to changes in the Earth's atmosphere by altering PCO2 concentrations and helped to initiate the late Paleozoic Ice Age. We can see on the right-hand side this image from Flugel, which shows how different organisms have controlled the growth of carbonate platforms through time. And those in turn have influenced carbonate platform morphology. So for example, in the earliest Proterozoic, we had microbial constructors forming carbonate platforms, then sponges and corals. But in the late Permian extinction, we lost a huge range of marine microfauna and macrofauna, including rugose and tabulate corals. such that microbialites began to dominate again in the Triassic before we started to get sponges and corals. And then in the Cretaceous, rudists started to form a major component of carbonate platforms. And they all influenced the shape and the size and the morphology of modern platforms. And so it wasn't really until the Tertiary, where we started to evolve modern coral algal reefs, that modern carbonate platforms started to develop. As well as composition, then the size and the distribution of platforms has changed through time. And changes in continental configuration due to the position of the continents and also volcanism associated with breakup of continents has changed concentrations of CO2 in the atmosphere to give us these fluctuations of greenhouse and icehouse events. And with that, sea level has risen and fallen, and Earth's temperatures have changed as well. Furthermore, that's changed our ocean chemistry composition. So during greenhouse periods, we see that seawater is precipitating calcite rather than the high magnesium calcite and aragonite that we see today. And that influences the composition and the reactivity of our sediments. So if we want to understand how our platforms, carbonate platforms, change during diagenesis, then we have to think about how ocean chemistry was influencing them when they were deposited as well. So I'm going to just move on and look at an example from a greenhouse period in the next slide, where we had very high global sea level, which created shallow epicontinental seaways, vast carbonate platforms. Similar conditions existed during the Devonian, for example, during the greenhouse conditions there. And that gave us situations like this, where this is a paleogeographical map of the Cretaceous, where we had these very large, shallow epicontinental seaways. Very, very different to what we see today. We don't see carbonate platforms in this way whatsoever. Thousands of kilometers in length. This is one of the hottest periods in Earth history. We had shallow seas over and low latitudinal temperature variations, and gave us platforms such as we see here in Oman, one stacked on top of the other. But because carbon dioxide in the atmosphere became so high, we had periods within the Jurassic and the Cretaceous where these giant carbonate platforms would die back because of ocean acidification. This is an example here from the Nati Formation in Oman, where we see almost acidity rising to levels that carbonate platforms were struggling to maintain the equilibrium of the carbon dioxide in the atmosphere, and couldn't serve as a sufficient carbon dioxide sink anymore. Very, very different to conditions we see today, although perhaps we might see in the future. And finally, we can't forget about dolomite. Through much of geological history, carbonate platforms have been dolomitized over tens to hundreds of meters of thickness, hundreds of kilometers, to give us these recrystallized structures that we see here. But dolomite isn't seen in modern oceans. If we go back to the Proterozoic, Neoproterozoic, though, we can see examples like this from Wallace et al. As an example in Australia, where these cap carbonates were forming contemporaneously at the seafloor. And so we see very different conditions in the past to what we might see in modern seawater today. So in summary, I can move my last slide.
Yep, if you can wrap up.
I've just crashed, so I think that's probably telling me to stop. So yes, in summary, carbonate platforms provide a record of a very different past than what we see today. And if we compare a modern carbonate platform such as this to past stromatopore carbonate platforms, rudist reefs, or even the giant salt deposits that we might see in the Permo-Trias, we're looking at something very, very different that we can't understand from looking at modern carbonate environments. And so I'd just like to wrap up by against the notion that the recent is not the key to the past.
Thank you, Cathy.
Thank you very much. Sorry, I've.
It's all right. The gremlins. I think the opposition will allow for gremlins there.
Thank you.
Okay. Right. Well, thank you very much. Thank you to all four of our speakers. That was, I believe, four very different, very compelling arguments there put forward. I've obviously, we've all been looking around here, and I've seen Twitter has been live with mentions of various artists and jelly beans and earth with and without vegetation have all been coming up. So definitely people are thinking about this. So we now offer those people that are thinking about this a chance to actually pitch, make their own pitch. So the idea of the floor debate is that the audience has 1 minute to put forward their arguments, their discussions, their ideas for either for or against the motion. So if anybody would like to speak, or hopefully there'll be quite a few people wanting to speak, please do raise your hand. Use the little raise hand button. Hopefully you can see that. It looks like this. There's my little raise hand button. So please raise your hand if you'd like to speak. This is not questioning. Well, if you want to ask in the form of a question, maybe the panelists will come back to that in their summaries. But I'm inviting people to speak. I've got one hand raised. Okay, now I have to find it in this long list of attendees. I will call, there it is. Dan Heron, thank you very much. Dan, I'm asking you to unmute now, please. Valentin, if you can you turn Dan's video on?
Yeah, I'm trying to find him in the list.
He's right up at the top on mine.
Is he? Normally mine is alphabetically ordered.
Okay, maybe we can go without Dan's video. If Dan, if you're happy to go without your video, maybe we'll just go.
Absolutely, no problem at all. I'm firmly on the side of what Will and Cathy were saying, and I can think of lots of examples why the present is not the key to the past. Looking back into the Precambrian, I can think of the banded ironstone formations, which make at least 2 separate stratigraphic appearances about 1 billion years apart. I can think about seas that were basically highly elevated in carbonate. You were having loads of stromatolites, thrombolites everywhere all over the Earth. We have glaciations of different types. We have snowball Earths, which may or may not have taken place. And not wanting to talk too much about glaciations, but going forward into the Paleozoic, we have glaciations that leave a drastically different records to what we see in younger or older periods of time. So I think that the problem is that when we look back into the past, we tend to neglect a large proportion of geological time that is represented by the Precambrian. And that's not even getting started on things like the Ediacaran, where we've got sort of strange experimental soft-bodied animals, and presumably that the paleontology was touched on well by Shahin and by Cathy, and I think that's where I think I stand.
Eloquently put. Thank you very much, Daniel. That's Dan Laheron, I think, phoning in there from Vienna. So, right, anybody else got any opinions on this, or are we all sold on the ideas of our speakers? I'm looking down the list of people we have in the room, and I know a lot of these people have very strong opinions. I'm starting to see some more hands. Amelia. So Amelia, would you? I don't know if you. We think we've resolved the video problem. So if you want to, you can turn your video on as well. Your option.
Right. Thank you. So I was wondering. This is partly a question to the excellent speakers that we had today. Is this not a matter of trying to formulate testable hypotheses on uniformitarianism? Because I feel like some of the examples you named are very convincing for either motion, but we're not always able to test them. So without defining exactly what would we need to find in order to tell whether this was different in the past or not, we might not always be able to finally decide. So I don't have a solution here. I'm just saying that it would be interesting to see more attempts to phrase hypotheses in such a way to offer a method to falsify them. That was below 1 minute, wasn't it?
That was just under 1 minute. It was actually, you had 10 seconds left if you want to say anything briefly. Hello, Mum, or anything. No? Okay, great. Thank you very much, Amelia. So anybody else? We've got plenty of time, so please just raise your hand if you'd like to speak. There's a lot of, I hesitate to say opinionated people that I see in the list, and I'm really surprised I'm not seeing more opinions coming forth. Anybody? Any takers? Are we all convinced by the arguments? I'll give it a few minutes more. I'm surprised to not see Valentin's hand go up. I normally see Valentin at this point in the any discussion. Oh, a hand has appeared. A hand has appeared. Sorry, it takes me a second to find them. Right, Marek, I will be allowing you to speak now. So, Marek, please go ahead.
Thank you very much. It's going to take 10 seconds probably, because Dan has already exhausted my list of the precarious examples. So I'd like to add only one thing, which is the red beds. Also the occurrences of red beds in the Precambrian suddenly appearing. and that's all. That's all. Thank you.
Thank you, Marek. Thank you to Marek. Anybody else? Oh, another hand's coming up. They're coming up fast now. Constantina, please.
Yeah,
you can
hi.
stop the video if you like. It's up to you.
Yeah, again. So hi. So I very much liked. Well, actually, I'm mixed in between, and I mean, undoubtedly, the past has many examples that are not. We cannot use the present to explain. And I very much liked Amelia's comment that we need something that we can test, otherwise we don't much do anything. But I think that the question in itself highlights that the problem is our perception. Human perception is limited. So if we think that the present is the key to the past, then we forget that we have to think outside of this box that is our present understanding. So it's also, but also if we keep reminding ourselves of this problem, then it would help us to highlight all the cases that the present is not the key to the past. So. Okay.
Thank you, Constantina. That was good points, well made. So again, reinforcing Amelia's arguments there. We still have plenty of time. We can take any more. Any more takers? No more. Oh, there's a hand. Every time I say no more, there's Chelsea. Chelsea, well, you can just talk. You have.
I can just bring myself right in. Yeah, so I think that a lot of this is a question of how you're addressing the question, because it sounds to me like one side, more the against side, is thinking this is uniformitarianism, and that changes or large-scale changes haven't occurred over Earth's history. But I think that the side that is arguing for the present being the key to the past is more along the lines of, and I sit with this camp, so I'm happy to join them, but that we can use the present and use what we know and what we can see and measure today to be a key to understanding geological times in Earth's past. So I think it's a little bit of a question of how you are addressing the question, and sort of your perspective on what you're really asking, what we're asking ourselves. And I think also along the lines of experimental work is giving us a lot of insight to how different conditions in Earth's past may have resulted in some of the things that we see in the ancient record, but don't exist in the modern. So things like elevating elemental concentrations and things like that.
Thank you, Chelsea. Chelsea's calling in from Germany there. We are, if people could mention where they're calling in from, that's actually quite handy. We know what our reach is then. So next we have Gnome. I will just, ask you to unmute. I think somebody was ahead of me there. Hi, hello. Right, and your video's on as well. Brilliant. Okay, go ahead.
Yeah, I'm from the UK. I just want to say that I completely agree with what Chelsea just said. I feel like a lot of the disagreements between the two sides here is more to do with semantics rather than actual disagreement. It's more about the interpretation of the question. But I don't think anybody is disputing that the past has been very, very different from the present. But it doesn't change the fact that we, as scientists, live in the present, and that a lot of the geology that we do is ultimately based on observations and experimentation, based on observations that we can make in the current world. So I feel like a lot of the disagreement here is more to do with interpretation of the question rather than actual fundamental disagreements.
Thank you very much, Noam, and brilliant phrase there. We as geologists live in the present. I'm sorry, as scientists, we all live in the present. Moving on, we have Kevin Taylor. Kevin, you've got your hand up. Please go for it.
Oh yeah, looking upwards, very wet and windy Manchester. I think I'm going to agree with Jeff here, which probably shock him. I think Jeff's comment was that the processes haven't changed, but the products have changed because the boundary conditions have changed. I think that's what we're really asking here. I think it's probably time I'm saying yes to both camps, I think, because I think the processes have not changed, but the products have changed. So I think there's probably a bit of both. So I agree with the previous two questioners, I think.
Thank you very much, Kevin. Anybody else? Please just stick your hand up and we'll let you in. I'll give it a few seconds more. Oh, there's an alarm going off there for an obscure reason. Okay. Nobody else? No more takers? I'll give it another 5 seconds. So, okay. So no more takers. I'm not seeing any more. Okay. Right. Okay. In that case, we'll move on. So that's the end of the floor debate. We've now got your thoughts, audience. We've got your insights, and so have our speakers. So they've been, if you notice, they've been frantically typing and occasionally laughing whilst the other side's been speaking. They've been sending messages to each other, and now they'll actually be arguing back against what the other side said. This is called the rebuttal portion of our show. And first we have Jeff. He has 5 minutes to rebut what he's heard from either from the other side, hopefully not from his seconder, hopefully from the other side and from the floor. So Jeff, do you have a screen to share by any chance?
I do. Can you just give me a second? Astonishingly, the sun has come out in Yorkshire, which is
sorry, I can't believe this. You're just
a set of conditions that are well outside anything that's happened in the recent. So if you just give me a second, I'll try and kill this. I'll be back. Give me a second.
Okay, we'll take one more from the floor if anybody wants to raise their hand. No. Okay, I'm frantically moving up. Oh, I've got Patricia Rosa is taking a. Go on, Patricia, go for it.
Hi, Steve. I just would like to raise 2 points of relativity of observation. I think most of the arguments that are about saying that it's not the key to the past are saying that things are different. And this goes towards Shahin was saying that even saying that things are different are relative to the present. But at the same time, I mean, time is relative. And I think most of the arguments depend on which time frame you are looking at. It seems that as also was said by William, that the farther we go in time, the more different, of course, things are. So it appears that most of the arguments of one side are about Precambrian or Neoproterozoic things, but at the other hand, when we're looking at modern sediments and trying to compare it to things like the Holocene or the Pleistocene, the argument does make sense. So that's the 2 points I have to make.
Thank you very much, Patricia. Two very valid points there, and I'm sure the sides will pick up on those. Jeff, are you ready with your presentation?
Yeah, I'm ready. I'll just share the screen.
Okay.
So everyone, I think actually Chelsea, Noam, and Kevin did a great job of summarising for our side. I think we are certainly not talking for uniformitarianism. Of course, we recognise that an awful lot of things have changed in the geological past. I mean, that's one of the really exciting things about being a geologist is looking at this, and certainly the other side make a super case for some of the things that have changed. I think, as was mentioned, our point is really about using what we know in the modern, where we can test hypotheses much more clearly. And there is a huge range of things today, even though we don't have the full range of history, there is a lot that we can see, and it does act as a comparator, as Shahin was saying. But I think we need to realize just how radical a lot of what we've learned from the modern and the recent really is. I mean, I'll give you just one example, but until the 1930s, 1940s, geologists thought that particles of any size didn't make it into the deep sea. They literally, you had coarse-grained particles at the coast, and then after that they got finer and finer, and it was only really when we started bringing back coarse-grained sand from thousands of feet or a couple of kilometers down and many tens or even hundreds of miles offshore that we realized that that something very different was going on to anything that we'd managed to get from our reasoning up until that point. And of course, that changed our whole view of what were called greywackies and what we now know as turbidites, the whole turbidity current concept and everything that followed. That all came from looking at the recent. Geologists have spent decades looking at the rocks, but without some guidance from the modern, they didn't have much idea. And I've just got one slide to respond to William and then one for Cathy. I mean, fantastic work that William and others are doing that he pointed out in terms of just how important vegetation in particular has been over Earth history. But I think if we're to understand it, again, we need to use the modern. So that lovely Davies and Gibbling diagram that you showed, William, that shows that in the sort of late Silurian, we start to see the change, at least that's what the statistics show, in terms of the amount of lateral accretion surfaces. And yet, of course, that doesn't come with a mechanistic understanding. And of course, everything we know about things that had tiny, tiny roots, these are the size of the sort of plants that you had at the time, they're tiny roots. Everything we know from the modern suggests that unless the roots scale with the bank, with the flow depth, then they have very little effect, because otherwise you just undercut the banks. And so actually there's no mechanistic argument that makes sense from everything we know on a testable basis for that relationship to be change in sort of river type to be related to those earliest plants. In fact, we've suggested in a paper that it's the other way round. Of course, if I was fighting for the other side of this debate, of course, I think I'd go for carbonates, because they're weird at times. I mean, that's not to say there's not a huge amount of work that's done on the modern that we can't use in the past, because at certain times in Earth history, carbonate systems looked more like they do today, but certainly at other times, they are very strange. But I think we're not denying that, of course, things have changed in the past. But I think what we would say is that we've got to look at this, if we're to reach a conclusion here, we've got to look at this in terms of all of our rocks. And actually, carbonates, in the grand scheme of things, are a small bit. They're about 20% of all the sedimentary rocks. And the bits that don't look and that we can't make actually reasonable comparisons with the modern are even smaller than that. So, Cathy, I recognize your fabulous points, but I'm going to sadly, despite the beauty, I've put up Malham Cove here, I'm going to argue that overall, they're not so critical. So, ladies and gentlemen, members of the audience, voting people, I therefore conclude that although things have changed in the past, and the past has much to teach us, I don't deny it, that if we're really to test things and understand things in detail, that the recent then really is the key to the past. It unlocks our understanding at much greater depths than any other approach. It acts as a comparator, and it's the basis that underpins, I think, so much of our science. So we invite you to step through the door, as it were, in the virtual world and join us in supporting the motion.
Thank you very much, Jeff. Thank you. That was bang on time, hence no warning. Very good. Thank you. So, William, you have your chance for the rebuttal. You also have 5 minutes. I saw you furiously taking notes when some of those root systems appeared on screen.
I wouldn't say furiously. Quickly. Quickly.
That perhaps wrong context. Yes. Okay. So do you have a screen to share?
Oh yeah, unlike Jeff, I haven't preemptively made some bonus slides, but I'm confident enough to talk if people
confident enough to talk without. Okay. Right. Okay. Challenge. Whenever you're ready, you start. I'll start your timer.
Okay, great. Yeah, I like my co-debaters have said it's been a lot of fun taking part in this. I think one thing which I would take up from it, and I think what we learned from Shahin and Jeff's talks, is if the recent really is the key to the past, then it's out of necessity. It's because we have no other frame of reference available to us. So then the question more becomes how appropriate is that? And we had people like Marek and Dan pitch in and talk about Precambrian examples, perhaps the least appropriate places in geological time where we can actually use the modern as a frame of reference. And we talked about the appearance of red beds or banded iron formations and their disappearance as examples of frequency distribution shifts preserved in Earth stratigraphic record that can be linked to biological change. How do you use the modern as a frame of reference to understand a banded iron formation? It's very difficult, and often you'd have to compare it to maybe things you see in the Phanerozoic, or in the Paleozoic, then the Mesozoic, then the Cenozoic, and actually take steps towards the modern to actually get somewhere close to the answer. Shahin, I thought, rather cleverly drew comparisons with paleontologists, and actually how we'd look at modern bivalves or brachiopods to understand those we see in the Paleozoic. But Dan introduced the Ediacara and macrobiota to our discussion. Well, by the same principle, we'd still believe that Chani and Mazanai and other of these Earth's earliest animals were still sea pens. At first we found these sort of frond-like organisms in places like the Long Mynd in the UK and Newfoundland in Canada, and they looked like sea pens. So by comparing to the modern, we assumed that they were plants, whereas actually by looking at the organisms in a lot of detail and detaching ourselves from that modern frame of reference, we now know they were animals. And that opens up whole new questions about how the animal kingdom actually evolved and whether the Cambrian explosion is a genuine signature or whether it's actually a slow, diffuse event. All right, so if the modern is truly the key to the past, then it has to be said out of necessity. And then to touch on a couple of things that Jeff said, both with regard to plants and carbonates, just because I get the last word. He mentioned the importance of rooting systems. I couldn't agree more. If you had piddly little roots in a Mississippi-style river, all right, yeah, they're going to get undercut and removed. But a lot of the work that Jeff's been involved in and others is how much mud, and it's the cohesion of that mud, that's actually required to enable a self-sustaining meander and as a result lateral accretion sets. And it's not much, okay? But it's not so much the below ground stature of these early plants that's important, but it's what's going on the bars, all right? If you add an above ground topography, it is a novel obstacle that never existed before, for the 3 billion years of the sedimentary record that predates it. Suddenly you add plant-induced obstacles, then you're going to reduce your Hortonian overland flow whenever there's a flood. That's going to increase the likelihood of mud being captured, and those small amounts of mud can trigger a positive feedback loop to lead to more mud. The new paper by Sarah Zeichner I showed with a little bit of organic matter production that can increase flocculation, all right? And those increased flocks will increase your total mud content. All these things can link to a muddy, self-sustaining, meandering river. So even if those early plants were quite small in stature, they still introduced novel effects, or most likely they still introduced novel effects, okay? I will recognize that that's comparing to the modern to make that assumption. But in terms of carbonates and the point that you made, and Cathy might correct me if I'm wrong, but carbonates have varied. Am I out of time? 1 minute, all right. Carbonates have varied in volumetric abundance throughout geological time, and things like in the Jurassic, they were far more abundant, or Cretaceous, they were far more abundant than they are today. In the Precambrian, they're virtually non-existent or far less volumetrically significant. So, carbonates I don't think can be really considered a uniform process throughout Earth history, and therefore that sort of idea of substantive uniformitarianism that I touched on earlier. But Cathy would be able to answer that better than me, but I get the final word, it seems. So yeah, I would urge everyone listening in to really think about the questions that we're trying to ask. If the recent really is the key to the past and you vote yes, then you have to admit to yourself that it's out of necessity. And if you think that there's additional factors, and one of our guests said that you have to think outside the box a little bit to make our interpretations of ancient stratigraphy. If you agree with that more, then I think for the sake of this debate, I would vote no. And I hope you do. You're going to tell me I'm out of time.
Yeah, I am going to tell you. You're bang on there, bang on. Perfect, William. Thank you very much, and thank you to all of our speakers. What we're going to do now is, before we open the vote, don't do it quite yet, Valentin. Before we open the vote, I'd like, because our speakers, due to the vagaries of Zoom, our speakers actually get to see the results. So I don't want their faces giving the results away. So speakers, would you do me a favor and just turn your videos off? Just turn off your video feeds for now, and also no exclamations. Right, okay, Valentin, if you could start the vote. We'll keep the vote open for 1 minute, and I do encourage everybody to vote. I shall not be voting as the chair. Unfortunately, I'm not allowed to vote. I'm hoping it doesn't draw, because then I have the casting vote, and given the arguments, it's not going to be an easy one to make. What we'll do is I will make some announcements though. Oh no, actually, oh no, it's going on quite well. Oh yes, that's it. People keep voting. Yes, we'll keep it open. Please, everybody vote. The more votes, the better. We want to see if there's been any change from how we felt before the proceedings. I'll give it another 10 seconds. So if you haven't voted yet, remember it's anonymous. No such thing as a wrong vote here. Okay, I'll give it 5, 4, 3. Oh, still coming in. 2, 1. Okay, Valentin, if you could close the poll now. Okay, Valentin's closed the poll. Now, Chelsea's going to compare our before and after polls, but while she's just doing that, I will make some announcements. Then I will ask our presenters to come back online. Some announcements while we've got you hooked while waiting for the outcomes of the poll. Next week, we're back to normal with our normal webinars, and we've got Stefan Baudin from Aarhus University, who's going to be talking to us about Jurassic environmental perturbations on shallow water, from a shallow water perspective. During the meantime, over the next week, please, everybody, visit our fabulous new website, join us in our coffee breaks, etc. Chelsea, first of all, presenters, can you turn your videos back on? Let's see your faces. Try not to give anything away. Stony faces. Okay, maybe not stony faces. Some of you should never play poker. So Chelsea, have you got the results? Here's the results. So I'm seeing an escape. I can't see the results because something came up on my screen. Oh, a big shift for, okay, well, the motion has been carried. The recent really is the key to the past. 58% for the motion, 35% against the motion, and 7% abstaining. The big switch there really seems to have been the abstainers. The abstainers seem to have switched to for the motion. I think we'll all agree there were a lot of good arguments there, and particularly in the perspective, the perspective, the time interval we're looking at here. I almost feel like there's a paper here, guys. Yeah, first Seds Online paper. But anyway, I want at this stage to thank everybody. I want to thank our speakers. You've all put in a terrific amount of work and imagination into putting together your presentations for today, and that is really appreciated. I want to thank the IS. I didn't thank them at the beginning. The IS sponsors all of the Seds Online activities. Basically, they pay for our online presence. So we really do appreciate that. I want to thank all the Seds Online that have been involved in Seds Online over the last year, and those that are still with us, and those that have spent time with us and then moved on to other things. So I want to thank everybody. I want to just reassure you that I think today was a success. I think we're going to have a crack at doing some more Seds Online Great debates in future. If anybody's got any ideas, please drop us a line, and we'll see what we can do with that. And I'm looking forward to seeing everybody at next week's Seds Online webinar. I'll ask the speakers to hang around now for a final little chat. But with that, I will close today's first Seds Online Great debate. Thank you very much, everybody. Thank you.